The views expressed on Science for the People are not necessarily the views of this station, its affiliates, sponsors, or advertisers.
This week on Science for the People, we're taking on the science of the sugar pill. We're talking about the placebo effect, its potential benefits, and its pitfalls. We'll speak with Erik Vance, author of the new book Suggestible You, The Curious Science of Your Brain's Ability to Deceive, Transform, and Heal, and Kathryn Hall, a genetic epidemiologist at Brigham and Women's Hospital and Harvard Medical School. We'll talk about why we experience the placebo effect, why some people are more open to suggestion than others, and why that might not be a weakness after all. Welcome to Science for the People. I'm Bethany Brookshire, a science writer with Science News and Society for Science and the Public. I'm here today with Erik Vance, a science journalist who has written for National Geographic, Slate, The New York Times, Scientific American, National Geographic, and many other outlets. He's a contributing editor at Discover and is the author of the new book Suggestible You, The Curious Science of Your Brain's Ability to Deceive, Transform, and Heal. Thank you so much for joining us, Erik.
Thanks for having me, Bethany. This is great.
Now, your book is about the power of suggestion and the many forms that suggestion can take. What exactly does it mean to be suggestible?
Well, that's actually a really great question, and it's kind of changed in my head over the last couple of years. I think when I started out, I thought of suggestibility as sort of this weakness, like it's sort of malleable. I often think for some reason of the scene in Good Will Hunting, the Matt Damon movie, when he's trying to get hypnotized, or this guy's trying to hypnotize him, and like he's acting like he's hypnotized, and then he's not, and it's like it's a big joke on the hypnotist because he tricked him. And what I found in the process of doing this book is that actually suggestibility in all of its forms is on the whole a strength. It's an opportunity to get in touch with a lot of different ways of sort of self-healing and self-care that isn't necessarily available to everyone. But in the case of hypnosis, a researcher told me that hypnotizability is actually a talent. And people are talented at hypnosis, who can be, they're people who can be hypnotized easily. So that's sort of how it's evolved in my mind. It's not really a purely scientific term. I mean, I'm actually lumping together a bunch of thematic things, things that feel like they go together, things that experts are, often interested in together, but they're not necessarily the same mechanisms, and they're not necessarily driven in the same way.
So when you talk about suggestibility, you also talk a lot about expectation and the power of expectation. What is expectation, and how does that differ from suggestion?
Well, that's exactly what's at the heart of my book, and so that is the thing that sort of links all of these things together. And expectation is sort of a psychological term psychologists use to refer to basically a very fundamental part of our brain, which is prediction. And Daniel Dennett and other people who are much smarter than me, who look at artificial intelligence, will often say that the brain is essentially a prediction machine. That's what it does all day long. And there are small predictions, like the ground in front of me is hard, or, I can step on it, or, if I drop this, it'll hit the ground. And there are big predictions like, I think the hunting will be good next year in, across the plains or whatever. But all of these predictions, that's what our brains do. That's what they were evolved to do. And, expectation in my mind is just a way to understand, the predictions that your brain has made and how they affect how your brain is navigating the world. And what's interesting, like for instance with placebos, it's an example of an expectation or a prediction that your brain has made that doesn't match with reality. And when that happens, when there's a disconnect, so your brain expects one thing and another thing happens and it's subtly different, your brain will often bend reality so that it matches the expectation, because your brain doesn't want to be wrong. And so your brain will make up the difference. Often with internal drugs, it'll actually drug itself, so that if it expects not to have pain, it will not have pain, and if it expects to have more pain, it will create more pain in order not to be wrong. And so that's really the element of expectation that I sort of dived into with this book.
So we were talking a little bit about placebos. Your book spends a lot of time on placebo effects. And what exactly is a placebo? What does that mean? People usually think of sugar pills, but that's not quite what a placebo is, right?
Well, placebo, I mean, at its heart, it's a Latin word that basically means I shall please. It was coined, gosh, in the early 1800s. Obviously it goes back much before that. Placebos are sort of loosely mentioned by like Avicenna who's a brilliant Persian physician in the Dark Ages, and even back to Hippocrates. In a way, they sort of refer to this thing that is this frustrating reality about the human brain, in that it will, as I said before, sort of push reality to meet its expectations, but it's today it has a much more central role in medicine, and but we don't actually call it the placebo effect. We actually call it placebo effects, plural, because there's many different kinds of placebo effects, and some of them are purely statistical. Like the one that people always talk about is the regression to the mean, which is that we tend to get better after our very worst point in being sick. So when you're the sickest, naturally after that you will get better, because otherwise it wouldn't be the sickest where you were. So and it's a sort of a statistical quirk that can look like a placebo effect. So if you take a pill at your worst, you will feel better afterwards. And that's interesting, but there's a lot of other types of placebo effects. There's psychological ones, but the ones that I was most interested in are the ones that involve brain chemistry, and the ones where your brain will actually step in and make the changes that it deems necessary. And so those are the ones that I got excited about. But placebo effects, it's sort of a broad term to refer to many different phenomena that can make it look like someone's getting better when they're actually not taking anything. And in addition to that, placebo effects also happen on top of an active drug. So if you're taking a drug, there will always be placebo effects on top of that. And the easiest way to think of that is, I don't know, have you ever had one of those headaches that's just like a throbbing, horrible, like pulsing headache, Stephanie? The one that oh my God, I hate this. And you go to the medicine cabinet, you're like, oh my God, this is terrible. And you take the pill, and then you drink that big glass of water, and you're just like, oh God, okay, all right. Have you ever had that experience?
I'm sure most of us have, yeah.
I mean, actually, I talked to a few groups, and some people say I have no idea what you're talking about. That is not what happens. For me, I take that glass of water and I just oh God, thank you. I can feel the relief. Well, that drug doesn't kick in for 20 minutes usually. So what are you feeling in that moment? That's the placebo effect. And some people I talk to when I get in front of groups, there's always a couple people who are like, that's not how it works. You have to wait for it to kick in. But then there's a bunch of other people who say, no, you feel immediate relief. So there's a variation in the population. But that's
wonder how much of that is actually maybe your throbbing headache is because you're dehydrated.
Well, that's another question, is it the dehydration? Is it just the stress that and actually if you could find some other way to relax a little bit that it would go away, or is it self-medication? Is it your brain releasing drugs because it expects it? And it's very hard to pull these things apart from each other. And there's some very clever scientists who work on this. It's that the point though is that, and that's a really basic example, but they get much more complex of how placebo effects can work in addition to drug effects, and it can happen at the same time too. If you have an immediate drug that kicks in right away, you can still have a placebo effect on top of that, which makes it really hard to separate all this stuff out.
In your book, you talk a little bit about the brain's internal pharmacy, and you also talked about the brain drugging itself just now. What do scientists know about what's going on in the brain when we experience a placebo effect?
Well, so one thing that we know is that there are rules, and this is what I think is really fascinating about this, is there seem to be rules as to how placebos work. If you there are some conditions have very high placebo responses, and other ones have very low placebo responses, and so the high ones, you have pain, you have Parkinson's disease, you have depression, anxiety, some autoimmune diseases, even asthma sometimes. These can have very high placebo responses, where other conditions have very low placebo responses, and that tells us that there's something going on. There's some rules at play that we don't fully understand. Now, the easiest thing to study is pain, because you can go into a lab and you can put someone in pain, and then you can take the pain away. You can't put someone in a lab and then give them depression and take depression away. I mean, I guess you could, but it's tricky. Same thing with a lot of people have actually done experiments with anxiety that way, trying to make people anxious and then take it away. But pain's the easiest. So when we talk about placebo effects, we're often talking about the research, talking about pain, because pain's the easiest thing to pick apart. And so we'll stick with pain for now. And a placebo effect on pain, the simple way to sort of understand it is essentially your brain is self-medicating using endogenous opioids. And so if you can imagine, I did an experiment where basically I was being electrocuted for about half an hour in this laboratory, and every time I saw green light, I got like this, this light shock, and every time I saw red light, I got this big shock, and it was like, and my foot would like twitch. I was in so much, it was not comfortable, right? I mean, and you go back and forth, red, green, and you can imagine after a while, I see that red light and I'd just be like, oh, sweet God. Oh, no. And then I'd shock. And on the last round, what they did was, it felt like that maybe the green one had been turned up a tiny bit, maybe from 1 to 2. And I was actually worried that maybe I'd short-circuited something in my nervous system. And what they did is they had actually given me the big shock every time. And, I swear I didn't feel it. Like, it wasn't like I was fooling myself. When I saw that green light, I didn't feel nearly as much pain. It was like a tiny bit more than it had been before, because your brain can kind of make up the difference, but it can't always go all the way, right? So it was basically self-medicating. It was dropping in morphine-like chemical, where it needed to be, exactly where it needed to be, in order to make the expectation, which was that green means low shock, into reality. And that's like a classic placebo response. And it's essentially the brain has a bunch of knobs in front of it, and it twiddles them to medicate, to medicate itself and to keep everything where it needs to be, homeostasis where it needs to be. And in that case, it saw something out of whack, and it just turned up the morphine knob so that I would feel less pain. And it happened, faster than I could even process the electrocution.
Well, as someone else who has done pain studies, I've been a subject in pain studies. Welcome to the club.
Thank you. That was not the last time I would endure horrible pain for this project. Next time I'm going to do I'm just something on like orgasms or chocolate next time, because this was terrible.
You need a break.
I need a break.
Hey, pain studies pay very well.
Yes, they do. Well, not me, but they do pay other people well. But so I think you asked like how this works. The last thing I sort of want to mention was, so you have this thing happening, and it's pain relief, and it's pain relief coming from your brain, right? So if you can imagine burning your hand and then putting it in an ice cool, like a bucket of ice water, right? And imagine that pain relief coming up your hand and feeling, oh God, yes, good. It goes up into your brain, and then it goes to the front of your brain. Goes through the hippocampus and the thalamus, and it gets the prefrontal cortex, where you do a lot of your higher reasoning, and you're just like, oh, this is great. I'm going to leave my hand in the bucket for a couple hours. Like that's, you can imagine that process. Well, placebo works backwards. It starts in the prefrontal cortex, and it works backwards, and it hits a lot of those same places in the brain, but sort of sending the suggestion backwards, so that and then the drugs are distributed. And Irving Kirsch, who is one of the legends of this field, once told me that reality is the wave of all the information coming from our body hitting the wave of information coming from our brain, and where those two waves hit, that's what we experience. And that collision, that back and forth, that pushing back and forth, that's where the placebo response lives. That's what we're talking about.
And there are some diseases and disorders that you mentioned, particularly in the book, that are very susceptible to placebo effects, particularly so. Some are less susceptible. Cancer is slightly less susceptible to placebo effects. But disorders such as irritable bowel syndrome, chronic pain, depression, and even Parkinson's disease are highly susceptible to placebo effects. Why are these disorders so prone to experiencing placebo?
Well, the simple explanation is chemistry. And that's what is just so mind blowing about this book and about the process that I sort of went through, is that this is. I had always thought of placebos as being sort of this sort of self-delusion or psychological effect where you're telling someone what they want to hear. But this is actually chemistry, so your brain has a whole suite of drugs at its disposal. And in the terms of placebo effects, it has a limited number of tools to play with. And take dopamine. Dopamine is a really important brain chemical in the brain. It's one of those like big boy chemical, like, that sort of, I think of it as sort of like a mob boss who's got his fingers in politics and, all these different places. Like he's really pulling the strings for an entire city, right? It's like, it has so many different jobs, so many different things that it does. And so you don't want to piss off dopamine. It's the way I always think of it. And one of those jobs is reward processing. And what is placebo if not a reward? Something that's going to happen. It's like a promise. And so dopamine, any diseases that are tied to dopamine are going to have a strong placebo response. And Parkinson's is a chronic deficiency of dopamine. So it makes sense. If we talk about the rules involved here, it makes sense that that Parkinson's would have, and sometimes phenomenally high placebo responses, and it would make sense that, and there's also a relationship between dopamine and endogenous opioids that we haven't fully teased apart. It doesn't take very long for this to get really, really complicated when you start trying to figure out what's upstream, what's downstream. But endogenous opioids seem to be part of this matrix, and endocannabinoids seem to be part of this matrix. If there are any pot smokers out there, endocannabinoids is sort of like an internal version of some of the drugs you find in marijuana. Serotonin seems to be in this mix. There's a bunch of other ones where actually the scientists are actually still trying to figure out this list. And I think you're going to talk to Kathryn Hall. She's been really integral in sort of figuring out this list of what the chemicals are that we have available. And there's I think there's something like when I wrote the book, there were like six or seven genes that have been discovered that link to these chemicals. Now there's like 30, and it just keeps getting more and more. So there's a whole bunch of chemicals involved, and where those chemicals intersect with diseases, you find diseases that respond very well to placebo. So pain, opioids, depression, serotonin. These are things that correspond. Now there's a lot of other conditions that just either don't have that chemical, or that for whatever reason they just don't have that opportunity. There's no way that placebo can access a way to change that condition, like obsessive compulsive disorder or Alzheimer's disease, or you mentioned cancer. Cancer is a really scary one because you can affect all of the symptoms of cancer with placebos. You can make the pain get less, the depression, the anxiety, all these things that go along, the nausea that go along with cancer, but not the tumor itself. So you can hide the cancer, but you can't affect it. And a lot of people sadly fall victim to that because they'll try to treat their cancer with things that don't work, and it might feel like it's working for a while, but the tumor itself does not respond well to belief. And so it's important to understand these rules and understand that there's reasons for them, and there's mechanisms going on behind the scenes that we're only now starting to sort of piece together.
And because diseases such as IBS and depression are so prone to placebo effects, we might think, well, that's a good thing. It makes people feel better. But it also means that developing drugs for them can be extra fun.
Oh my God, what a nightmare.
What percentage of people, say, with depression experience placebo responses during a drug trial? How strong is this?
Well, going back to placebo really goes back, in modern history, back to the sort of the 1940s when there was a scientist named Henry Beecher who he was actually a medic, or he was actually sort of a head medic in World War II, and he saw these crazy things, and actually many of the things he saw weren't actually placebo responses. He saw this one guy who had this giant gash in his back, this axe wound like thing in his back, and he didn't complain about it. And when they gave him a shot of morphine, he complained about the pinprick in his shoulder rather than the thing in his back, and that's actually a form of distraction, but which isn't a placebo. But it got Beecher thinking about how does the brain mediate pain, and like he had all these great charts. He took a bunch of data because he was a giant nerd, and after the war, he really pioneered this field and sort of started asking these questions about, what is this thing called placebo? And before then, it had been coined, but it really wasn't commonplace to really, it really became, it was used in the early part of the century, sort of in science experiments and people who had questions to answer, but it wasn't like it is today where it's required to see if a drug works. And so he wrote this great paper called the Powerful Placebo, and in it he sort of said it makes up 30% of responses. So 30% of people will respond who are taking placebo will feel better, right? And that's something that people continue to say over and over again, and it's lasted until today. But it's not exactly true. It's a broad generalization, and what the truth is that different conditions and different situations have different placebo responses, and some of them I've seen down at 10%, or 15%. Others can be, I've seen, the bad ones like pain and depression. 50, 60. I was just looking at a paper the other day that had 70% of people responding to placebos, and it was relatively large. These differences tend to get smaller with larger groups. If you get the larger, more powerful statistics, they tend to go down to, in one case I was looking at a psoriasis paper, and a large analysis that this pharmaceutical company had done said that they can expect a placebo response of 40%, even with a large group of patients. We have that sort of that enough statistical power to sort of figure out what's really going on. But in a smaller group, I actually once saw a paper that it was like, I think it was like 98%. And it was a small study, so they didn't have a lot of subjects, and they got really unlucky. And essentially everyone who took the placebo felt better. And that study is basically worthless, right? You can't compare it against anything. But I think 50 and 60% for for some of these conditions is not uncommon. It's very much something that you have to contend with, like in an academic setting. And then even if you get a really big sample size, you still could be looking at 40-45%. That your drug has to outperform that, because and believe it or not, especially in early trials, that's a high bar to think that you can have a drug that will outperform essentially half of your patients getting better on nothing. That's asking a lot of a drug.
We're talking with Erik Vance about his new book, Suggestible You, The Curious Science of Your Brain's Ability to Deceive, Transform, and Heal. Now, Erik, we've been talking about the placebo effect, but there's an opposite effect to the placebo called the nocebo. What is that?
It's a fascinating study. I always think of it as the nocebo. The placebo means I shall please, and nocebo means I shall harm. I also sort of think of it as sort of like discipline for a dog. No Sibo if you have a dog named Sibo. And the nocebo is a really interesting, fascinating phenomenon. Oftentimes, I was talking about pain earlier. Oftentimes, anytime you're doing a pain study and you say this is gonna hurt less, this is if with me it was like the green lights is gonna hurt less, or there's many different ways to set these things up, and there's usually this will hurt less. There you can always do it, and maybe in the same study you can have an opposite reaction, which this will hurt more, this next thing is going to happen. You're expecting more pain as opposed to less pain, and that's the nocebo response. At its very basic, it's basically an expectation of increased pain, and unfortunately, it's very hard to study. You can study it again with pain in a laboratory, but you can't. We don't know a lot about placebos, but we've learned a lot through research and with Parkinson's and things like that. We know even less about nocebos, because you can't go up to a Parkinson's patient and say, here's a pill that's going to make your Parkinson's worse, and you need to take this for the next 2 months, and it's going to make you a lot worse. Like, you can't do that. That's not right. That's not ethical, and it's just frankly kind of evil. And depression. Imagine going to a clinically depressed patient and telling them they're going to take a pill and it's going to make them worse. So as a result, it's very hard to study nocebos and to understand the mechanisms. We understand them a little bit with pain, but a lot of these other ones, it's very hard. The one thing we do know about nocebos is they're easier to create than a placebo. With a placebo, there's often a lot of classical conditioning, which is what we were talking about before, with the lights going on and on, like on and off, and like green and red. That's training my brain to expect a certain outcome, right? It's sort of training an expectation. And that's conditioning. I mean, this is the thing that Pavlov did with his dog. But a nocebo doesn't require that. All you have to do is say, this is really going to hurt, right? You ready for this? This is going to hurt a lot. And your brain is programmed for fear. It's ready for fear. It doesn't need to be primed. And in some ways it's kind of sad to say it, but in some ways fear is more powerful than hope, because it makes evolutionary sense. I mean, you're better safe than sorry in a very deep sense. So that's one thing we can say about nocebos. They clearly affect many parts of our lives, and in my book I talked to some scientists and I spent some time in the science, but then I also go further afield, and I get into questions of superstition and mass hysteria, and then I even go so far as to get myself cursed by a witch doctor just to see how my own negative expectations would affect my life. And that's maybe a little further afield from the true nocebo from a laboratory, but these nocebos, they are tied into a lot of elements of our lives, and that that are tied to fear and negative expectations, and also tradition, culture, and superstition. Like, they're all wrapped up in this stuff.
Placebo effects, suggestion effects, they're rampant in alternative medicine. Mm-hmm. And they're also really rampant in professional sports. For example, many people were really struck by the gigantic bruises that Michael Phelps was sporting at the 2016 Olympics. And they were the result of a procedure called cupping. Yeah. Cupping is not supported by science, but athletes are pretty superstitious people with good reason. And the placebo effect might have helped a little, but sports and placebos in medicine, especially, raise a lot of ethical questions. Did you talk to any ethicists about using placebos?
I didn't actually. I know, and I know this is there. There are a few folks out there who have really started looking at this, and I didn't really. I get into some of these issues, and I'm continuing to go down and look at some of these issues, but there are a lot of really interesting questions, and I'll just put one out there right now for you, since you brought up sports. Imagine that morphine is a performance enhancing drug. I don't know if you knew that. It's illegal in a lot of different competitions, and because just at a certain level, performance is a matter of withstanding pain. There's a certain level at which athletic performance is simply just not feeling the pain and pushing yourself through the pain. And if you can block that pain, well, then you have an enormous edge. So morphine is illegal in a lot of different sporting events.
Your book covers how placebos and suggestion, including practices like hypnosis, can have these very real effects. But many of us who might be of more a skeptical bent might think of placebos in a kind of negative light. So, for example, we might smile at people who are using homeopathy. They're basically drinking water, and tell ourselves, oh, they're just experiencing a placebo effect. And pop culture might lead us to believe that only the silliest people in Scooby-Doo get hypnotized. So hypnosis is for people who are weak-minded in some way. And this produces kind of a scorn on the concept of placebos and the power of suggestion. But it seems in your book you kind of came to a very different view of this.
I did, and I can't pretend that I don't still have those feelings that you're describing. In fact, I just talked to someone yesterday. I was on a walk and started talking about this. I mean, once you start thinking about this, you see it everywhere. And I was talking to a woman who was doing a type of meditation and movement, and she was talking about the science behind this. And I was sort of, snickering because she was talking about the difference. The science has shown that if you hold your hand one way versus another way, you have more, you can create more power. And of course, science hasn't shown that. But in fact, she is tapping into something that is measurable, and that's placebo effects. And these things are not. It's easy to think of, a lot of sort of new age alternative medicine is sort of the best way to access these things. And for her, and I haven't talked about the theater of medicine, but there's a theater through all of this, and there's different ways that you can tap into your expectation, and maybe it's ancient mysticism, and maybe it's sort of cutting edge science. And for her, she kept talking about the science that was proving that this one hand motion that she was doing was more powerful and created more energy in her than another one. And for her, that science that created expectation, that she needed that for her confidence, to create the belief that this was going to work, to create that expectation that her body would then fill, would then make true. And these are powerful things. Like, this is a way of self-hacking. And it's, if you have access to that, you are the lucky one, and it's not clear. I know you're going to talk to Kathryn about whether or not some people are more prone to placebos than others. And it's a huge question, and one that scientists have been trying to figure out for a very long time. But if it's true, if there are people who are able to use alternative medicine reliably and treat things like chronic pain, those people are lucky. And those people are the ones who they have access to healing that the rest of us just don't have. And And that's what I really came to understand. And it's really hard, actually, very hard to internalize that and to really believe it, because it's very obviously clear that, I mean, hypnosis is the best example of this. Some people, hypnosis is much more stable than placebos, so it doesn't change through our life very much. So if you're hypnotizable, you'll always be hypnotizable. And if you're not, it's going to be very hard for you to become more hypnotizable. And I'm not hypnotizable and the assistant who was working with me when I was doing the hypnosis chapter, she was, and she has access to so many more healing therapies than I do. I mean, she can go get hypnotized and deal with all kinds of pain and depression and get access to parts of her mind that I just don't have access to. I'd love to have that. And I'd love to be able to try placebos and have them work. Luckily, if you read this book, it won't affect your ability to have placebo effects. A lot of these things are subconscious. They're beyond our reach. You can even suspect that something is a placebo if you do homeopathy and you suspect maybe it's a placebo. If it works for you, that you can't really control that. That's going to be it's a subconscious process, and it's beyond your reach. So this won't, understanding this stuff won't hurt your ability to have these placebo effects. But it is important to read this book because there are limits. There are limits to this to alternative medicines and placebo effects and hypnosis as well. And those are don't hurt yourself if you're using these techniques. Don't use them if you have a life-threatening disease, and don't use them if they involve maybe some dangerous chemicals. Don't go broke. It's the second one. I talked to a lot of people who spent their life savings trying to chase a cure that was never going to happen, and that breaks your heart. And the last one is don't hurt the environment. If your particular alternative medicine placebo hacking tool involves endangered animals, pick another one. There's lots of them to choose from. Don't do something that's gonna cause another animal to go extinct because our belief requires it. But within those rules, and with hypnosis, I often say don't play with your memories. Don't try and pull up memories that don't exist or that you're trying to find. That can lead to terrible consequences. But within those rules, there's a lot of room to play with your own expectation and to create healing in your life. And it's not like we're not already doing it. We all do it. 70% of doctors say they occasionally prescribe placebos to people, knowing that take 2 of these and call me in the morning kind of thing. This is something we do. This is something we have always done, and it's very much woven into the fabric of culture and society. So don't be afraid of it. I mean, that's what I really realized. And I'm not a great responder to placebos, but I wish I was, and I sort of tried to become more so because it's a powerful tool.
Well, Erik, thank you so much for being here with us.
Oh, thanks for having me.
His book is incredibly thought-provoking, raises a lot of questions, and kind of made me wish I responded to placebos more. We have linked to Erik Vance's new book, Suggestible You, The Curious Science of Your Brain's Ability to Deceive, Transform, and Heal at our website, scienceforthepeople.ca. Next, I'll be chatting with Dr. Kathryn Hall, a scientist who studies the genetics behind what might make some people placebo-prone, while others remain relatively placebo-proof.
Science for the People is a weekly radio show and podcast that explores everyday life from a scientific perspective. We are a member of the Skeptic Network, a collection of blogs, podcasts, and video content focusing on science and critical thinking. To find out where Science for the People airs near you, or to listen to past episodes, check out our website at scienceforthepeople.ca. You'll also find links to support us at Patreon, to connect with us on Facebook and Twitter, and to subscribe to the podcast in iTunes. And now, back to the show.
Welcome back to Science for the People. I'm Bethany Brookshire, a science writer with Science News and Society for Science and the Public. I'm here with Kathryn Hall, a genetic epidemiologist at Brigham and Women's Hospital and Harvard Medical School. Kathryn, thank you so much for making the time for us.
My pleasure.
Now, we just spent some time chatting with Erik Vance about his book Suggestible You, which includes, among other topics, some of your work on the placebo effect. How did you become interested in studying the placebo effect?
Well, Bethany, I spent about 10 years in the pharma industry, and one of the most striking things of my experience there in drug development was just how many people respond to the inert treatment, to the placebo. And also, just kind of the broad range of responses to a treatment. You spend your whole time in drug development trying to make the drug the same way every time. And you have to hit very narrow specifications to make sure that when somebody, opens a capsule or takes a capsule, that they're getting that 800 milligrams plus or minus, a very small window. But once the drug gets out there into the real world, people respond very differently. And I was really captivated by that. So kind of the spectrum from an inert treatment to a drug, the many responses was really, I was very curious about why that is. And I quickly hit upon this new field at the time called personalized medicine or pharmacogenomics, which is now essentially called precision medicine. And I was captivated ever since.
And many of us have heard of the placebo effect. We know it's the experience of having an effect of an intervention, such as, say, a drug or a pill, when in fact the intervention itself had no effect. The drug was a sugar pill or the surgery was a sham. Can you take us through what we know about what's going on in the brain when someone is experiencing a placebo effect?
There have been several types of studies that have given us a glimpse into what's going on in the brains of people when they're having a placebo response. And these insights have come from pharmacological studies. So the studies of, treating people with different types of drugs and seeing how they respond, and also from neuroimaging studies. And the pharmacological studies were in the 70s. And there was a group that was basically doing teeth extractions and then studying the placebo response around the pain post-tooth extraction. They quickly learned that if you extracted a tooth and, kind of did a sham treatment with morphine, you could have a very strong placebo response that was equivalent to about 8 milligrams of morphine. But if you gave the person the drug naloxone, you could block that placebo response. And naloxone is a drug that blocks signaling through the opioid pathway. Basically, your endorphins. It blocks these molecules that relieve the pain in the brain. And so that was the first inkling that we had that the placebo response might be using the body's natural pain relieving mechanism. Fast forward to the 2000s when neuroimaging started to become available, and what they then found out was that if you gave somebody a placebo, they didn't know it was a placebo, you would see not only the opioid activation in the brain, you would also see dopamine activation in the brain. We quickly learned that there are many systems that are being activated in the brain in the process of responding to placebo.
Now, you talked a bit about depression. There are some disorders that are exceptionally prone to experiencing the placebo effect, and that includes depression, but it also includes Parkinson's and pain. And many of these have the chemical dopamine in common. Dopamine keeps popping up. What role does dopamine play in the brain and in these disorders?
So dopamine is one of my favorite neurotransmitters, if you will. Because dopamine does so many things. It works in your brain, but it also works in many other parts of your body. And dopamine is involved in you understanding whether something is a reward or not. In moving, so motor movement, dopamine is involved in the experience of pleasure. And fascinatingly, dopamine is also involved in blood pressure regulation, in making new blood cells, angiogenesis. And it also even signals to the white blood cells in your body. So dopamine is one of these ubiquitous, or these these molecules, these neurotransmitters that is everywhere, but is doing very specific things in the areas that it is made.
And dopamine has many molecules that are associated with it. It doesn't just send messages on its own. And you're interested in one of these molecules in particular. It's catechol-O-methyltransferase, or COMT. Thank you, I worked on that. So COMT. What is COMT and how does it work?
COMT, which we affectionately unfortunately called COMT, is an enzyme that basically breaks down dopamine. So dopamine is made in your body, in your brain. It's made in it's complicated. It's made in various parts of the body, but dopamine, once you use it, you don't want to have it around. Once you've had your sense of reward, once you've done your motion, you want to get rid of it. So there are many enzymes that break down dopamine, and COMT is one of them. And it basically clears out not only dopamine, but other molecules that are like dopamine. Believe it or not, epinephrine or adrenaline and norepinephrine or noradrenaline are two other molecules that COMT also gets rid of after they've done their function.
And most of us probably know that molecules such as COMT, or really such as anything, are made when DNA makes RNA and RNA makes protein. And so mutations or changes in the DNA can affect the RNA and the protein, which ends up changing the structure and potentially the function of the final product. COMT has a bunch of mutations that can affect its function, and you're particularly interested in one. It's called Val158MET. What is this, and why is it important?
Every gene has multiple, what we call polymorphisms, or many changes, to kind of interpret the word. And one of the ones we like to work with is that Val158MET, because it basically at position 158 changes an amino acid called val or valine to met or methionine. And what's cool about that is that many polymorphisms don't change the protein structure. They don't change an amino acid. They just change the DNA. And because that part of the DNA isn't involved in making the protein, we don't really fully understand why that's important. But with Val158MET, it's very clearly causing changes in the activity of COMT. So people who have the Val version of COMT have a really strong working enzyme. It breaks down dopamine very efficiently. But people who have the MET version of COMT, their COMT enzyme works 3 to 4 times less efficiently than the people who have the Val version. So they actually have more dopamine around at any given time.
And when we say that people have a Val version or a MET version, there's also something in between, because of course you have 2 copies of every gene. So there's people who are Val-Val, they have 2 vowels. There are people who are MET-MET, and then there are people who are Val-MET. They have 1 of each, right?
Exactly.
And,
so basically that's genetics, where your parents each have 2 copies of the gene. And so they could have the Val version, like your father could have 2 Val versions, and your mother could have 2 MET versions. And you as a child would get a Val version from your father and a MET version from your mother. So you would be a Val-MET.
Now, this particular mutation, the Val158MET, has behavioral effects that are associated with it, associated with those changes in how COMT breaks down dopamine. And these include cognition, memory, and pain processing. These are all correlations, of course, but what kind of behaviors could someone with 2 METs be more likely to show as opposed to someone with 2 vowels?
Well, as human beings, there's so much variability, even when you have a very obvious change in a gene, because there are 20,000 genes in the body, and on it, for any given gene, there's a network of genes that it works with. So, although we like to simplify things as scientists, and we have come up with this warrior hypothesis, for Val and MET, it's never that simple. And so what you often see, for instance, are some studies where people with one version are more likely to have an idea of committing suicide, for instance, if depressed. In another study, that will be different. That being said, people have coined this warrior hypothesis, and what they think is that people who have the Val version, who have less dopamine, are less sensitive to pain, and they're quote-unquote braver. They're the warriors. And people who have the Met versions, who have more dopamine, they're kind of like thinking more about like, do I want to rush in where angels fear to tread? And they're the warriors. And so these are the kinds of behaviors that people have observed that are different between people with these two genotypes. But within those, there's a lot of variability.
It makes me think of the Hogwarts houses in Harry Potter that
Exactly.
maybe the Vals are the Gryffindors and the Mets are like Ravenclaws.
Perfect.
Now, you chose this particular COMT mutation to examine the placebo effect. Can you take me through how you tested that placebo effect?
Sure. In around 2008, between 2008 and 2010, we did a really interesting study where we gave people different types of acupuncture. What we wanted to do was we wanted to basically give people different doses of placebo. So if you basically just, make a call and go to the doctor and you haven't been seeing it, you're kind of in the waiting room, that's kind of the first basic level of a placebo, right? Then when you get into the room and you see all the symbols, you see the white coat and you see the stethoscope, and the technician might come in and say, okay, I'm going to give you a shot, right? These are that's the next level of placebo treatment, if you will. But the third level of placebo treatment is that warm, caring interaction that many of us really benefit from. When the doctor, takes your hand and puts a hand on your shoulder, and she, listens to your heart, and she says to you, I understand you're not feeling well. Tell me about it. So what we wanted to do was we wanted to compare these different doses of placebo treatment and see who responded more to each level. And this study was done, and it was clear that overall people responded more to this warm, caring person who, even though they were doing sham acupuncture in this case, there was a very strong response to that. The disease that was studied was irritable bowel syndrome, and people with irritable bowel syndrome tend to have a lot of abdominal pain, constipation, and issues basically surrounding their abdomen that really affect their quality of life. And so in this study, what we found was that the strongest dose of placebo was a combination of being seen by your practitioner, getting fake acupuncture, and these people had the greatest decrease. The people who got that treatment had the greatest decrease in their abdominal symptoms. So fast forward to around 2012, what we wanted to do was we wanted to ask the question, did people differ in their response to these three treatments based on what COMT genes they had? And when we did this study, what we found was indeed the people who had the Val version or the warrior version of the gene, they had very minimal response in every single arm of the trial. So it didn't matter if they were on the wait list, sitting in the waiting room, if they were getting just the intervention, so the sham acupuncture, or if they're with the actual acupuncturist who was really engaging them and holding their hand and, taking their pulse and giving them the sham needles. It didn't matter to them. They did the same in each arm. But the Met people, the people who had two versions of the Met low activity COMT enzyme, basically people who had more dopamine available in their brains, they had a very, very strong response, not to the waiting list, not to the sham acupuncture, but to the warm, caring interaction. So what we realized is that a great deal of the placebo response is driven by that patient-doctor interaction. And that's very, very important to at least a subset of people, and most likely to the Met people.
Now, these Met people you mentioned have higher amounts of dopamine potentially floating around. How might that increase their placebo response? What's going on?
Well, we're trying to figure that out. But basically, if dopamine is being activated in the brain in response to placebo treatment, and actually this is not necessarily true for everybody, when you're having a placebo treatment, not everybody has this increase in dopamine. In fact, some people have a decrease in dopamine in their brains, and they tend to be the placebo non-responders. So although we don't know fully how it's working, we can see a correlation, and we at least understand that more dopamine tends to be better. We tend to feel better. There tends to be a signal to your brain that things are good. You've received a reward.
Now, you found there's a difference in sham acupuncture with a caring person response between these two genotypes. How do you think studies like this on the placebo effect might affect healthcare and healthcare studies of medicine in the future?
Well, I think medicine is just the beginning of how it could help. Firstly, in medicine, if you know that your patient is more likely to respond to the warm, caring interaction, then obviously that's going to be an important part of their care. And many medical schools now have, patient Dr. One, if you will, where physicians are taught from an early stage in their career to really have a good bedside manner. And what we learned is that this may not be important for everybody. And obviously, we want everybody to benefit from their clinical encounters. And so what we're also trying to understand is for the placebo non-responders, what helps them get better? Obviously, the drugs play a large part of this. But is there any part of the patient in the doctor interaction in that clinical encounter that can be improved for the people whom the warm, caring piece is not necessarily benefiting them? Or do we need to worry about that?
And in this case, the placebo effect was elicited mostly by a provider who was just very nice and warm. But many placebo effects are elicited by sugar pills or sham surgeries. What are the potential pros and cons of using that effect of giving people fake medicine in the clinic?
Well, we're still trying to figure that out. I think it's complicated because as we've dealt with time and time again, it is unethical to deceive a patient, to basically tell them you're giving them a treatment and not give them a treatment. And for many, many years, there's been a belief, basically since, World War II, when clinical trials took off, that you have to deceive a patient. They have to be blinded, if you will, to placebo treatment, or else it won't work. And so it's unethical, therefore, to give a patient a placebo if you don't tell them that you're giving a placebo. And the belief is that if you tell them, it's not going to work. That alone is very interesting. But what Ted Kaptchuk and other researchers in the program in placebo studies at Harvard are doing is they're testing that paradigm. They're testing whether or not they can give a patient a placebo, tell them that they're getting a placebo, tell them that placebos have actually been shown to be beneficial to some people, and seeing if they have a response that's a positive clinical response. And they've done about 3 trials on this now in irritable bowel syndrome, so people who have this abdominal pain, in depression, and in fatigue and nausea around cancer treatment. And what they've found is there are people that will have a positive response to a placebo pill if told that they're actually receiving a placebo pill that could benefit them. So how this will be translated into the clinic remains to be seen. I think it's too early to tell because obviously from our data, it's not going to benefit everybody, but certainly we want to benefit the people whom it would benefit.
Kathryn, we're out of time, but thank you so much for making time to chat with us.
You're very welcome.
We've linked to Kathryn Hall's papers, including an open access full review of the genes currently associated with the placebo response from our website at scienceforthepeople.ca. You'll also find links to Twitter, Facebook, and iTunes, where you can listen to past episodes, subscribe to the show, or leave a review. You can also find our Patreon page, where you can support our intrepid little band of podcasters with a monthly donation. Thanks for listening, and we'll see you next week on Science for the People.
Science for the People is produced by Rochelle Saunders and edited by Ryan Bromsgrove. Helen Quivalon is our publishing liaison. We get research help from Josh Witten and consulting support from Desiree Schell. Our frequently seen guest hosts are Marion Kilgour, Anakin Hazra, and Jessica Yaros. Our theme song is called Binary Consequence, and it was written and recorded by Fractal Pattern. Science for the People is entirely listener-supported. You can find us on Patreon, where you can support us with monthly donations in any amount, or you can send us a one-time donation in any amount via the donate page of our website. Science for the People is created in partnership with the Skeptic Network, a collection of blogs, podcasts, and video content focusing on the intersection of science, popular culture, politics, and social justice. You can find out more about Skeptic at skeptic.org. The show is hosted by science news writer Bethany Brookshire and me, Rochelle Saunders.